Hey everyone, and welcome. Today, we are going to deconstruct the absolute value function. Now, I know it can look a little intimidating with all those bars and numbers, but trust me, once you see how it's built piece by piece, you'll see it's actually super simple. So let's dive right in. So before we even touch a graph, let's just back up and ask the most basic question of all. When you see those two little vertical bars around a number, what do they even mean? What are they telling you to do? At its heart, absolute value is just about one thing: distance. How far is a number from zero? And think about it. Distance can't be negative, right? It's like a positivity machine. You put in -5, it asks, how far is that from zero? The answer is 5. You put in +5, same question, same answer. A positive number always comes out. So here's our roadmap for today. We're going to start with that classic V shape. Then we'll figure out how to move it around the graph. After that, we'll see how to change its shape, make it skinnier or wider. And finally, we'll put the whole shebang together. It's going to be a step-by-step build that'll make total sense by the end. All right, let's kick things off with section 1. You see, every single absolute value graph you will ever encounter is just a tweaked version of one original, fundamental graph. So let's meet our starting point, the parent function. And here she is, simple, elegant, perfectly symmetrical. This is y equals x. That sharp point at the bottom, right there at the origin, 0, 0, that's called the vertex. Think of this as our home base. Every change we make from here on out is just going to be a transformation of this one single shape.
Okay, but why a V? It's a really good question. That shape isn't just random. It's a direct result of that positivity machine we were just talking about. The math itself actually forces the shape to happen.
This table right here, this is the secret. Look what happens. When x is positive, like 1 or 2, y is exactly the same. That gives us the right side of the V, a straight line shooting up. But when x is negative, like -1 or -2, the absolute value kicks in and forces y to become positive. That's what creates that perfect mirror image on the left side. See? It's that simple. Okay, so we've got our basic V down. Now for the fun part. Let's start moving it. This section is all about shifting that entire graph up, down, left, or right without actually changing its shape at all. And the most important thing to get here is where the change is happening. If you add or subtract a number inside those absolute value bars, you're going to get a horizontal shift, left or right. But if you do it outside the bars, you're going to get a vertical shift, up or down. Let's see what that actually looks like. So here's our first shift. Y equals absolute value of x minus 3. Now, this is the one that can feel a little weird, a little counterintuitive. You see, we subtracted 3 on the inside, but look what happened to the graph. The whole V shape actually moved 3 units to the right. The vertex isn't at 0, 0 anymore. It's over at 3, 0. The vertical shift, on the other hand, is way more straightforward. Here we've got y equals x plus 4. We added 4 on the outside, and, well, look, the whole graph just moved up by 4 units. The vertex is now sitting at 0, 4. That one makes perfect sense, right? All right, so now we know how to move the V all over the place. Next up, let's figure out how to actually change its shape. We're not going to move it this time. We're going to make it narrower or wider. And the rule for this is super simple. It's all about multiplication. When you multiply a number on the outside of those absolute value bars, it acts like a stretcher. It basically controls the slope or how steep the sides of that V are. Just take a look at the green dashed line here. The equation is y equals 2 times x minus 3. See that 2 out front? That's our vertical stretch. It's basically grabbing the V and pulling it upwards, which makes it twice as steep and, as you can see, a whole lot narrower. Okay, this is it, the moment we've been building towards. We've learned all the individual moves, the slide left and right, the slide up and down, and the stretch. Now we're going to combine all of them to break down one complete transformed function. So here's our target function, y equals 2 times x minus 3 plus 4. And here's the exact order we're going to build it in. We always start with our parent function, y equals the absolute value, and then we just apply these transformations one at a time. Let's watch it happen on the graph. Okay, watch the screen. We start with that blue parent function, our good old y equals x. First move comes from inside the bars, that minus 3. And like we learned, that's going to slide the whole graph 3 units to the right, which gives us that red dashed line. So far, so good. Next up is that multiplication, the 2 out front. This is our vertical stretch. So watch the red line. As soon as we apply that 2, boom, it gets pulled up, becoming twice as steep. Now it's the narrower green dashed line. We're almost home. And for our final move, we look at that number hanging out on the very end, the +4. This is a simple one, right? It just tells us to take that entire green graph and shift it straight up by 4 units. And that gives us our final destination, the solid orange line. We did it. We built the whole thing from scratch. And that's really the big takeaway here. It doesn't matter how complex or scary an absolute value function might look. Underneath it all, it's just our simple friend, y equals absolute x, that's been moved around and stretched a bit. If you can spot those transformations, you can graph absolutely anything. So that leaves us with one last thing to think about. We've totally mastered these rules for the V shape. But what if your starting shape was a parabola, that classic U shape? Do you think these exact same rules, the inside changes moving it sideways, the outside changes moving it up and down, do you think they would still apply? Definitely something to chew on.